Alrighty, welcome to a sort of a continuation class from yesterday. If you remember from the slides yesterday, this is what we were discussing. The official title was Horizontal and Vertical Scaling, Indexes in Databases. Basically understanding some advanced concepts in both databases as well as in servers. Yesterday, we discussed about vertical scaling in Node.js and something about called the cluster module that lets you vertically scale Node.js. What is vertical scaling? We'll get to very soon. I'll revise everything from yesterday for the first 5 minutes or so. Then we did some capacity estimation yesterday. I shared that there is something called auto scaling groups in AWS that let you scale horizontally. I also discussed a little bit what does horizontal scaling mean. Today, we'll first revise for 5 minutes everything we did yesterday. Then we'll discuss a little bit more about horizontal scaling. Then we'll go through auto scaling groups, load balancers, and a bunch of other AWS constructs. I think that'll be it for today. All database advanced stuff will probably be an offline video for this week. That's my current sense based on how slow the class went yesterday. That's enough context, I think. Anything else I want to share? No, that's it. Let me quickly revise what we did yesterday. Yesterday, we first discussed scaling is a thing in a Node.js application, in a Rust application. If you're building a backend of anything, you want to scale it up. And what does scaling it up mean? It means you want to increase the number of servers. You want to have much more powerful machines. For example, if this is your AWS machine that is currently T2.medium, which is let's say a 2-core machine with 4 GB RAM. If you have a lot of load, you will try to increase it to T2.large or T2.xlarge, so on and so forth. So this is one way to scale your application. What is this called? This is called vertical scaling. You are increasing the size of your machine. But the problem is that JavaScript is single threaded, which basically means doesn't matter how many cores your machine has. For example, my Mac has a 10-core machine. My Mac is a 10-core machine. The JavaScript can run on a single core of my machine. It cannot run on multiple cores. So there is no point of vertically scaling your machine unless you change your JavaScript code a bit. How can you change your JavaScript code? We discussed in this slide called implementing, this should be vertical, scaling in a Node.js project. We said there is something called the cluster module that lets you spin a bunch of child processes using cluster.fork, very similar to if you've done forking in C++. You can fork a process, which means if my machine has X number of CPUs, let's say 10 CPUs, I will fork my process 10 times by calling cluster.fork, which means I will have 10 Node.js processes running locally, which will all be running this Express code right here. What is this Express code? Just creates an app instance for Express, defines a simple route, defines a more complex route, and then listens on a specific port, which in this case is port 3000. So I was able to start the Node.js process 10 times, yet have it listen on the same port. Even though I'm running, if this is my very beefy machine, usually what do? We start a single Node.js process, which means if your load increases, your single Node.js process can get overwhelmed. So what did we do? We started multiple Node.js processes, and we also said all of them are listening on the same port, specifically the port 3000 in this case. And the requests are getting routed to, each of the process based on some round robin or whoever has the least load, whatever that algorithm is. The requests are getting routed to one of these child processes. That is when you can vertically scale Node.js process. You cannot vertically scale a Node.js process if you write code the way we have written it until now. Unless you use the cluster module or some other way for you to start multiple processes together. For example, a naive way is to just start 10 node index.js in 10 terminals. Unless you do this, your vertical scaling makes no sense in a Node.js application. That is what we discussed yesterday. Then we spent some more time on capacity estimation. Vertical scaling is one way, but there is some limit to how much vertically you can scale. You can get a 20-core machine, 40-core machine, 50-core machine. But at some point, if you have a very big machine and everyone's sending the request to the same machine, that's problematic because you will have bandwidth restrictions. If you have a billion users, doesn't mean you will, infinitely vertically scale. Okay, I will create a very big machine, the biggest supercomputer that is out there, and it will handle all the requests. No, that's not the best idea, because, number one, you are being too dependent on a single machine. If the machine goes down, you have a single point of failure. Number two, you are telling all million people to connect to the same machine. What if someone is in India, someone is in the US? Your machine can only be in the US, and hence India people have a lot of latency. So ideally, you should horizontally scale. What does horizontally scaling mean? Okay, you should have a bunch of servers, not just one. Each server can be very powerful, that is fine. Each server can have Node.js running in cluster module, that is fine as well. But there should be multiple servers. And whenever a user goes to your website, which is, let's say, app.100xdevs.com, let's say, the request goes to a load balancer, which, is a machine in itself, which, as the name suggests, this is a load balancer. As the name suggests, balances the load. So sends the request to one of many servers. That is how you horizontally scale. Why is it called horizontal scaling? Because, at least theoretically, you can say, I'm adding more machines horizontally. I'm adding a bunch of machines right next to each other. That is why it is called horizontal scaling. And what is vertical scaling? If you increase the size of your machine, that is vertical scaling. Horizontal scaling is more popular. You usually have, a single instance type. Let me choose a T2 medium machine, and then I'll auto scale it up and down as the load comes and goes. If you feel like you have a lot of load, then you might choose, whatever, T2.x large machine. But in the end, you can only vertically scale until a point after which you begin to horizontally scale. Today we'll understand how do you horizontally scale by using some AWS constructs, specifically something called an auto scaling group. That is what most of today's class is going to be. One quick call out of two architectures that we discussed yesterday. These are slightly complex architectures, so even if you don't understand them, it's fine. The easiest way to do auto scaling is, here I will have only one machine initially, but as the load on this machine goes above 50%, I will add another machine. And now the load should probably be 25% because I doubled the number of machines. Load should half on each of the machines. Then let's say more traffic came, and then the load again became 50%. What do I mean when I say load? I mean CPU usage. If it became 50% again, then I will scale up one more time. Then, the net load on the system would be 33%. Then let's say, more requests came, it became 60% again. Then I will scale up again, so on and so forth. This will become now whatever, 40%. Now let's say load went away and this went down to 25%. Then we'll be like, let's scale down. If we scale down, then also this will go from 25 to 35%. That is fine. Then let's say it went down further. Then you can delete another machine. This is the easiest way to auto scale based on either incoming bandwidth or incoming request count or CPU usage or average CPU usage of your cluster. So these are the easier ways to scale where you don't have any ad hoc logic. What do I mean when I say ad hoc logic? I mean something like this architecture. For example, yesterday we discussed if you have a chess-like game, if you have a real-time game like chess, then you will have a bunch of machines. Let's say this is an AWS machine which has 6 cores. So I'm running it in cluster module. I have 6 processes running here, 6 processes running here, so on and so forth. And all of these have persistent connections to the users. All of these have WebSocket connections to the user. So this guy also has WebSocket connections. This guy also has WebSocket connections, so on and so forth. And let's say in Node.js, if you are creating WebSocket connections, 10,000 is a good number. If you have more than 10,000 users, you will start to create issues or you will start to face issues. So here you are not dependent on CPU usage or something else. You are dependent on what? You are dependent on some number. How many people are currently playing? If 88,000 people are currently playing, then you want 9 machines, because what did we say? If more than 10,000 people come, it's a problem. So this is ad hoc scaling. There is a metric that you own. These metrics that we talked about are something that the cloud provider is able to automatically get. So you don't have to do a lot of effort when it comes to scaling like this. You just have to tell the cloud provider, in this case AWS, these are my rules. If the incoming bandwidth average should be 50%, goes up, you increase the number of servers, go down, you decrease the number of servers. This is more ad hoc logic. And the Cloud provider doesn't know this. There is no option to see the current open connections. Or, for example, something like this, what are the number of requests? Well, requests per second you can actually see if you're going through a load balancer. So you don't really need this specific architecture for, Paytm like application. You can just tell AWS, please scale up or scale down based on CPU usage. But here, you aggregate a metric, you throw it out, and then this metric is what tells the auto scaling group in AWS, please increase to 10 servers. I now have 88,000 people. That's a lot of people. My WebSocket server cannot handle them. This is called ad hoc scaling. I don't know what it's called. This is just, this is something I named ad hoc scaling in this class, whatever this is called, in which case you own the metric based on which you scale. And it's a very, your system dependent metric. What can be another good metric for a use case? Another use case we discussed yesterday was YouTube like platform that transcodes videos. So here, as people come to your YouTube platform and upload a video in 1080p, let's say, this 1080p video needs to be converted into 3 videos, 720, 1080 and 360. And hence, this process can take a really long time. If I upload a 2-hour video on YouTube, this transcoding can also take 2 hours sometimes. So here also, if people come and upload to your website, you need to start machines for them. You need to start machines for them that are transcoding their videos. So if 3 people have uploaded videos, you might have 3 servers which are currently transcoding their videos. Here, a good metric on which you should, decide the number of machines that are up could be a queue length. The length of the queue, which stores the currently pending videos. As people upload to your platform, you push their video to a queue. This person has uploaded a video. What ideally happens is, you upload a video to a cloud provider. You upload your official video, your 1080p video, whatever your video editor gave to you, you upload, and it actually first goes to whatever, S3 or, some object store. Of course, it doesn't go to S3 for, YouTube, because YouTube is owned by Google. Google would never use Amazon or AWS, but it goes to some object store. So firstly, you are on a dashboard. Whenever you upload a video on YouTube, if you've tried, you're on a dashboard, the video is getting uploaded from your browser up to some object store. Once this is done, then this location of the video is pushed onto a queue. There is this video ID that Harkirat has posted, ID 1, user ID 2 has posted a video which is present, in the object store somewhere here, S3:/ some location, Harkirat videos /123. Let me make this slightly better. This is the first thing that goes into the queue. And as more people upload, this queue keeps on getting filled. Why am I doing a queue architecture? Because we don't want, this system cannot directly tell a worker, please transcode. This worker might be busy transcoding someone else's video. So you asynchronously handle this task. You send it here. And then this queue length keeps on increasing. Let's say there is a spike. Everyone starts to upload. Then this queue length will become 100. And this is the metric that based on which you scale now. 100 videos are pending. We should probably scale up to, 200 or like 50 servers, so that, at least 50% gets transcoded in the next hour, and then the rest 50% in the next 1 hour. So here, again, it's an ad hoc metric. The queue length is what decides the number of currently active workers. So this is the third way. Today we will discuss both of these architectures, as in implement, not discuss. We will implement both of these architectures. How do you do auto scaling using both these metrics, either an ad hoc metric like this or a simple metric like CPU usage? How do you scale up and down on AWS? Cool. Let's get right into it. Let's get into some coding. I think that's enough context, and the rest, whatever you did not understand, in case you did not, even though I feel like this is fairly slow, happy to take doubts eventually. Anyways, when we code a little bit, you'll understand this maybe a little bit better. Horizontal scaling. Horizontal scaling represents increasing the number of instances you have based on a metric to be able to support more load. If you want to support more load, based on a metric, you scale up or you scale down. AWS has the concept of auto scaling groups, which, as the name suggests, lets you auto scale the number of machines on a certain metric. Now, a call out here. This isn't the cleanest approach to do this. Auto scaling, there are a bunch of ways to auto scale. The better way to auto scale usually is using containers. Okay, you don't start a machine again and again. You have some either very big machine somewhere where you start containers, and as the load increases, you start more and more containers. Here, containers are much more lightweight and easier to start compared to what we're doing right now. What we're doing right now is literally starting multiple EC2 machines, and each. Hello. One second. हुआ तुम्हारी साइड इशू है यार. मैं एक बार पोल कर लेता हूँ, एक सेकेंड. कैन यू गाइस सी माई स्क्रीन गाइस? यस और नो? तुम्हारी साइड इशू है. Bro, my phone number got leaked in a video and now everyone in the court has my video. My phone number, sorry. Alright. What was I saying? Yeah, what we are doing is literally starting multiple machines. Basically by the end of what we are doing today, what will happen is you will literally go to your console and you can see that more machines are being created here in EC2 and then machines are going down as well. It's the most raw way to auto scale. How people would have auto scaled before containers weren't a thing. Today auto scaling happens usually via containers because they're much more lightweight, which means much more easier to start. An EC2 machine takes at least 20-30 seconds to start, right? So that is why this isn't the best approach, but this is a great approach for a long time if you want to avoid Kubernetes, if you want to avoid containers, if you don't have containers in your company right now. The easiest way, the most raw way to auto scale is this. In AWS, it's called auto scaling groups. I'm sure every cloud provider has some flavor of this where you can auto scale up and down. But auto scaling, in itself requires a bunch of things. You are starting a bunch of machines. This machine needs to have Node.js installed. This machine needs to have your code that actually needs to execute JavaScript or TypeScript code. So you have to somehow create a snapshot of your machine. This is the machine that I want to bring up or bring down as my scale increases. So there are a bunch of buzzwords to know before we actually proceed. These are AWS or Amazon specific buzzwords, but you'll find them in some form or fashion in other cloud providers, either with a different name or a very similar name. The first buzzword to know is something called images or Amazon Machine Images, AMIs. AMIs are snapshots of a machine from which you can recreate more machines. What are we going to do today? We will take a simple Node.js application, and the first thing we will do is we will create an EC2 machine, and here we will install npm node and then get our code from GitHub. Then we will create a snapshot of it. We will create an image from this EC2 machine. This is the first buzzword to know. What is the benefit of creating an image? If you have an image ever, right, you can create multiple EC2 machines from it. You don't even need an auto scaling group, even without it. Even if you have just an EC2 machine from which you created an image, now you have a snapshot of that machine. So you can keep recreating this machine, which will have npm node code, whatever was the current state of this machine, the file system, all the libraries that you had installed, you have a snapshot of it. And why is this useful? Because using this snapshot, we can create more EC2 machines as time goes by. This snapshot is something we will have to give to the auto scaling group so that the auto scaling group knows that this is how I want to start my new servers as the scale goes up. So that is the first thing to know. What is the second thing to know? Load balancer. Hoping it's self-explanatory. What does the name say? Load balancer. As you have multiple machines, 1, 2, 3, 4, they will have their own IPs, they will have their own domain names. But your end user only usually sees what? Your user sees api.100xdevs.com, right? So your end user only sees this. What does that mean? That means this request needs to get handled by either a single machine or something else. It's not necessary that a load balancer is a single machine, but something needs to handle this and route the requests to one of many machines that exist based on the load, and hence this thing is called a load balancer. Harkirat, can I create a load balancer myself? Can I just start an EC2 machine which takes requests from the user and then routes them to various machines based on the load of the machines? Yes. You don't necessarily need to create a load balancer in AWS. You can just create an EC2 machine, start some sort of a load balancer, proxy implementation there, and that can just handle incoming requests and forward them to here. Nginx lets you do pretty much what we're talking about. So if you want, you can own this as well, but usually you defer this to AWS. Why? Because it is a fully managed service, which means you don't have to worry about scaling it ever. It might happen your load balancer becomes a bottleneck. What if there are 1 billion users on your website? They cannot be handled by a single machine. You have 1,000 machines to handle the 1 billion requests. But if you have a single load balancer, then this will be a problem. So AWS, thankfully, spends a lot of time, effort here because they know this is a load balancer. This will be the first entry point for all the users. So they make sure they scale up, scale down, have machines in various regions so that whenever your load increases for whatever reason, they're able to handle that incoming load. That is why it's a good idea for you to use load balancers from AWS rather than create your fresh machine and deploy one there. Target group. This is very AWS specific. So this might not exist in any other cloud provider. A group of EC2 instances that a load balancer can send requests to. Whenever you start a load balancer, how do you tell it, if you're receiving a request, please send it to this machine? You tell it you are part of this target group, and then you attach every machine that's here to that target group. Here you are part of target group T1, 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 and T1. This is just how AWS expects you to link a load balancer to your machines. It says, don't give me the actual IPs of your machine or your actual IDs of your machines. Give me a target group, and the target group is what will, be connected to various machines. It just creates a easy distinction if you have a target group, because then, I can have another load balancer where also I can say, you also will route all requests to the target group T1. And we can say this guy also will route requests to a target group T1. Another place this will be useful is because when you create an auto scaling group, the auto scaling group, whenever it adds more machines, it can simply tag those machines with T1 so that the load balancer can send requests to them. We'll come to this very soon when we're implementing it. But one buzzword to keep in mind for now is target groups, which let you attach to instances / machines. And whenever you start a load balancer, you tell the load balancer, whenever you're receiving a request on port 443, you will be forwarding it to this target group. Lastly, a launch template. A template that can be used to start new machines. You might say, Harkirat, that is what an image was. Image was exactly this. Okay, you create an image, and using this image, you can start multiple machines. What is a template? The thing is, image just takes a snapshot of your machine. It does not take a snapshot of, these are the ports that were currently open on this machine. It doesn't attach, the storage on this machine was 8 GB. And a bunch of other things. For example, when this machine starts, this script should run. Node index.js should run, or pm2 start index.js should run. All of these things cannot be part of the image. Image only is the file system and the current snapshot. Okay? It looked like this. It had these libraries in these folders. A launch template has the image also. This is the image that we will be starting with. This is the image that we want to launch other things with. And this is the security group of it. What is the security group? What all incoming requests are possible? This is the key pair that can access this machine. This is the starter code. When the machine starts, we need to run pm2 start index.js in this machine, so on and so forth. That is what a launch template is. So there's a big difference between AMI's images and this. When you start an image, when you start an instance using just an image, if this is an image and you start an instance using it, you have to tell explicitly, this new instance that I'm starting, this is its security group. This is the space that it needs to have, 16 GB. Versus if you have a launch template, every machine that starts will have the same security group, same key pair that can connect to it, same command that will run when it starts, so on and so forth. So that's the last buzzword. Again, this will get very easy once we start implementing it. So let's just get right into, the AWS dashboard if you have it. I will do a very big call out here. There are a lot of resources we are creating. We will create images today. We will create launch templates. We will create load balancers. And these are, expensive. They get charged. And whenever you are stopping machines, you forget, you just stop your machine and you forget about it. But, one thing about auto scaling groups is, to an auto scaling group, you tell, bro, I need 10 machines ready. And if you go to your AWS dashboard and stop 10 machines, it will restart them. So if you are coding along or, trying this along today, make sure you do a very nice cleanup at the end. I will do it myself. But, long story short then is going to be, you have to go here to AMIs and delete all the images that you have. Go here to auto scaling groups and, delete the actual auto scaling group over here. And not just stop your EC2 machines. If you stop your EC2 machines, they will just restart. The auto scaling group will just restart them. All right, cool. Let's get right into it, guys. Let's start to deploy an application. I already sort of did this before the class. Let me quickly show you what we're doing. As you can see, let me give a brief of what's happening. I currently have 0 instances. I have 0 EC2 machines. Let's say I want to deploy some Node.js application here. What can I do? I can either launch an instance, install Node.js there, start it, and it doesn't even auto scale. Or I can create an auto scaling group and I can tell the auto scaling group, okay, my desired capacity is 3. My desired capacity, the number of machines that I want started is 3. Minimum desired capacity is 3. Maximum desired capacity is 3. Harkiyat, what is minimum and maximum? This is an auto scaling group, right? It can go up and it can go down. Minimum and maximum means it shouldn't be less than 3. It shouldn't be more than 10. We will have at least 3 machines. We will have maximum 10 machines. And based on some metric, they'll go up and down. I updated this. I said, bhai, 3 minimum is my desired capacity, which means 3 instances will now automatically start. I have an image attached to this auto scaling group, which is why, they will know, okay, this is the code that we have to start. This is the image that we have to start from, and it will start to run my application. But if I go to EC2 here now and wait for like 10-15 seconds, you will see instances will get started. I can also go here to instant management and see there are 3 instances here. They are currently pending, which means they are currently starting. But once they start, I should see them here as well. As you can see, it said 2. There you go. I have 2 instances initializing. Eventually they will run. And if I wait for a bit, the third one will also start. I have 3 of them now. Did I go here and click on launch instance? No. They automatically started. If I delete them from here, if I do this actions, instance state, stop. If I stop them, the auto scaling group will restart them, which is why I'm saying by the end of the class, don't feel like you will stop and that's good to go. You have to go to the auto scaling group and either decrease the capacity to 0. Ideally, just delete your auto scaling group. By the end of the class, this specific application is actually deployed on a URL, lb.100xdevs.com, which stands for, loadbalancer.100xdevs.com. It isn't working right now, probably because the machines haven't started. But once the machines start, they actually start the Node.js process that's running there. LB, which stands for loadbalancer.100xdevs.com, should, go to one of these 3 machines and, we'll have an internet deployed URL here. Notice one more thing. If you look at this lb.100xdevs.com, it is deployed on HTTPS, and the certificate that you will see here is an Amazon certificate. It's not a certbot certificate, if you remember the certificate management class. So we'll also discuss how do you create certificates in Amazon. All right. The website is deployed. And as you can see now, lb.100xdevs.com returns hello world. If I go to lb.100xdevs.com/count/1 or API/1, I think is the route of the code. There you go. What does it say? Final count is 950, which means what is 950? We'll look at the code very soon. This is the code from yesterday. 950 is the process ID of the Node.js process that's running on that machine. If I refresh this, you will see it keeps changing. What does that tell you? Tells you my requests are going to various machines, and also in every machine they're going to multiple cores. So as optimal as it can get, we have both horizontally and vertically scaled. So that's the final thing we are arriving at by the end of the class. Let's start from the top and let's see how you can do it. Let me quickly scale down my infrastructure and make these 0. And that's all I have to do. If I go to EC2 dashboard now, you will see they'll start to spin off now, and these will go to stopped very soon. That's the benefit, right? It's very easy to scale up and scale down. All right. With that, let's kick things off. What's the first step here? What do you think? The first thing is you need to create the image from which other instances will start. For which you first need to create an instance of your own. So step one is launching an instance in which you will bring Node and your code base. The code base that we're dealing for today is this one. Like, feel free to use your own code base. But if you look at this file, this is the code that we had yesterday, which is it hard codes total CPUs. Ideally, this should come from the OS library, something we discussed yesterday. If you don't understand, it's fine. And it starts multiple processes on the same machine, which pretty much do this. Const app equal to express, app.get slash, app.get slash API slash :n, and then app.listen port. So they start an express application. If this is too complicated, remove all of this, cluster logic that we have. Simply have a simple express application, code from here to here. That is also fine. We don't have to worry about application logic at all today. You can deploy any application, doesn't matter what. Step one is cloning this on the machine. So let's create a machine first. Let's click on launch instance and fill up all the things that are needed here. Now we have already done this a few times, but I'll still take you through all the steps, but I'm hoping they're straightforward. Let me call my machine week 22 auto scaling group class. Let me select Ubuntu as the operating system. Instance type can be anything, doesn't matter. Micro should be fine because doesn't matter what you create your image with. You can always whenever you're spinning up more machines, you can always select a more beefier machine. So T2 micro is fine. Key pair, I'm hoping some of you already know. Those of you who don't know, let me quickly share. Key pair lets you connect to the AWS machine. Whenever your machine starts somewhere on the internet, you want to be able to connect to it. And to be able to connect to it, you need some sort of a password, right? You don't want anyone to be able to connect to it. This key pair is the easiest way for you to connect to it. It uses a protocol called Secure Shell, if you've heard of it, SSH, which is something used to connect from here to a machine on the internet. For example, if I go to my terminal here and type ssh-i kirath.pem kirath-aws.cer ubuntu @projects.100xdevs.com. If I type this command, which starts with what? Starts with SSH, secure shell. It needs to have a key pair as an input, which, assume it's a very long file for now. If I share this file with you, then you can also connect to my machine. And what is this machine? This is the machine that deploys projects.100xdevs.com. If you look at it, now I am connected to Ubuntu at some specific IP, which means I'm connected to that machine. I have a secure shell to that machine. If I press ls here, I see all the folders that currently exist on this machine. So that we can eventually connect to our machines in our auto scaling group, it's a good idea for us to either create a new key pair or select an existing one. Let me create a new one just so that people who are creating one with me can follow along. Create a new key pair, give it whatever name, week 22 AWS class, and doesn't matter, choose either of the key pair type, choose either of the format and download the file. Now this is my PEM file that has been downloaded. Let me copy it and move it to a folder here on my machine. You might have downloaded the same thing and moved it somewhere. One very important step you have to do next is change the permissions on this file. If you don't change the permissions on this file, you will not be able to SSH, which means just go to your terminal and run the command chmod space 700 space the name of your PEM file, which in my case was week-20-22-AWS class. So this is the command that you have to run. What does this command do? It restricts the permission on week 22 AWS class. 700 means it will have a lot of permissions as this admin of this specific account. but the other accounts on this specific machine, my Mac machine, will not have read-write access to this PEM file, which is something that AWS expects you to do before you connect to their machine. Otherwise, they will give you a very standard warning. If you Google that warning, it will give you this command. Just put this command and that fixes it. All right. Cool. Done with 3 steps. Quick recap. What did we do? Gave it a name. Selected Ubuntu over here. Selected t2.micro over here. Created a new keypair file and downloaded it. You can create a security group here. Even if you don't, it's fine. You can eventually, whenever you create your auto scaling group, overwrite it. I'll just leave the defaults here for now. Allow SSH traffic from anywhere, which means after this machine is started, I can connect to it using SSH. Size doesn't matter. You can change it later on. So 8 GB is good enough. That's it. Click on launch instance and that should start your machine. Now if I go to my AWS dashboard, I will see this machine that is starting. And what are the next steps? I need to go to this machine, install Node.js, clone my code. These are the 2 things I have to do before I proceed to image creation. So let's wait for this machine to start and then we'll go from there. Just to get a quick check, how many of you are doing this along with me? Are you doing this along with me? Yes or no? Are you coding along on your own Amazon machine? Okay, mostly no only. Yeah, that makes sense. Cool. Then I can, increase the speed a bit because you can always come back to the offline video. Alrighty. The machine is running, which means I can connect to it. How do I connect to it? Copy the public DNS or the IP, doesn't matter, either one of these things. Open the terminal and run the same command I ran a few minutes ago to connect to my other machine. What is the command? SSH-I, your PEM file name. Mine was week-22-aws-class.pem, Ubuntu at the rate of the address. And you will see I am now connected to the machine that I just started. This is the machine running. I can see it here on my AWS dashboard. This is me connected to it. What is it? This is effectively a machine somewhere in the US or, currently I'm in Mumbai region, which means somewhere in Mumbai, and I'm connected to it. I have access to it. Cool, right? Like you can rent machines on the internet. All right. Next step, install Node.js. There are many ways. There is my favorite blog post over here by DigitalOcean, which I just used and, copy commands from here to here to install Node.js. This also shows you multiple ways to install Node.js. For the purpose of this tutorial, whatever follow along, I would urge that you install it using NVM, which is Node Version Manager, which is how I am going to install it as well. If you install it using the other methods, it will mostly be fine, but it might become problematic later on when we reach something called the user data in the launch templates. So I would urge you to just, do the same thing I'm doing. Else you might run into some things that you can debug, but yeah, it's just easier if you just follow along. All right, so that is NVM. So there are a few ways you can do it. The easiest one that I usually use as well is using NVM. NVM stands for Node Version Manager. Installing Node using the Node Version Manager. This is the first command to copy. Ignore this command over here. This is the very first command and paste it here. This will install not Node.js, but Node Version Manager on my machine. And what is Node Version Manager? As the name suggests, it lets you bring various versions of Node.js to your machine. When you copy this command and paste it here, it will give you an export that you have to sort of copy and paste. You can also just exit from this terminal and then you re-SSH. That will also work. Or you can just copy the export that it gave you by the end and paste it over here. And you should have access to something called NVM, a CLI command line interface called NVM that you can now use to install Node.js. The next command to run is nvm install node. All right. This should install Node.js on the machine. What was the next step? Cloning your repository on this machine. That should be straightforward. Go to the repository. Happy to link it in the chat as well. And then just quickly clone it on the machine. Make sure you select HTTPS over here and not SSH. Copy this URL to the repository, or just copy this as well, that will work. And then run the command git clone, and whatever the URL is. Then just try to see if it works. Go to week 22, try running npm install, try running npm run start, and see if it works. And I see some logs, which means it does work. I can also test if it works or not by doing what? By going to first the security group over here and opening port 3000. The problem is that port 3000 is where this specific, application is hosted, and we haven't yet added an inbound rule for port 3000. So just to check, you can ignore this as well. As long as you see, this thing here, logs here, it means your application is working. But if you want to really confirm, what you can do is go to your security group. So basically click on your instance here, click on security, select the security group here, and edit the inbound rules. What does it say? You have one inbound rules. I am allowing SSH access from anywhere. Anyone can hit the port 22. Now I will add a rule that says anyone can hit the port 3000 as well, because the port 3000 is where this application runs. If you go to index.ts, the port that we have here is port 3000. So I'll go here and add an inbound rule. Custom TCP 3000. Anywhere IPv4 should be fine. Save. And now if I go to EC2 machines and try to hit my machine on the port 3000, you will see hello world, which means my application is deployed on the internet. Now it has a bunch of problems. Problem number 1, the URL is very ugly, has a :3000 at the end. Problem number 2, it says not secure over here. Problem number 3, it is not auto scale. If a lot of people hit this, we're screwed. That is what we'll fix slowly and steadily through the rest of the video. All right. Step 1 is done, which was installing all the things on your machine. Step 2 is creating an image out of it. So click on whatever the input box is, like your specific instance that you want to create an image from, and select actions, images and templates, create image. That should create a snapshot of your instance at the current point. So if at the current point my instance has, a folder called week 22, then my image will also have it, and any machine that I start from it will also have it. It'll be a snapshot of this machine. Let me name it week 22 image. You can, 8 GB is fine. Feel free to increase or decrease it, and then click on create image. What does it say at the top? Currently creating an Amazon image called this from instance this. Check the status to see if the image is created. So it will take some time for the image to be created. Let's go back to the steps. What was step 1? Create an EC2 machine, install Node.js and clone the repository there. We have done that. What was step 2? Create an image from your machine. That is also done. Step 3 is creating a security group for your final auto scaling group. Your final auto scaling group will have some, inbound rules, things that you want to open up. And you can create it later on as well. So you don't really need this step basically. But yeah, feel free to create a fresh one just for consistency. So what can you do? You can click on security groups here. So this is like an optional step. Feel free to skip as well. But if I'm doing it, feel free to do it. Click on security group and create a new security group. Call it week 22 class. Allow 3022 access. And add a few inbound rules here. Not outbound, inbound rules. Anything that's hitting port 3000 should be allowed. Anything that's hitting port 22 should be allowed, so that the final machines that get created, I can SSH into them and see what is happening. Is that are there any issues? If I want to see the logs, let's say, so I'm opening port 22. I'm also opening port 3000. You can close this as well, or you can restrict this a little bit more to be like only allow traffic from the load balancer to the instance, what are we doing finally? We are saying, okay, the final machines that we are creating, that will horizontally scale, and this will be the load balancer. We are saying the port, there are two ports open here, 3000 and 22. Why 22? So that I can connect to them later and see what's happening inside. And why 3000? So that the load balancer can access them, or discover them. Discover was the word I was looking for. But you can make this more restrictive. Here 3000 here shouldn't be open to the world, because now the world can also hit this on port 3000, which is fine. But it's generally you want to make sure that this is not open to the world and only open to the load balancer. So you can make it more restrictive. We have opened it up for now, just for debugging purposes, so that we can actually see the EC2 instance :3000 as well. That's it. That's all that you have to do. Make sure you give it a name, because this name will come later on when we're attaching the security group to the launch template. Create security group. Is the pace okay? Are we good to go, guys, or should I recap? Are we good to go? Yes or no? Oh, we're not good to go. All right, taking a pause here, guys. What's up? Let's open Q&A. Recap. Unable to create image. What error do you see when you create an image? Recap. What is a security group? You should go back to the EC2 instance class. But security group says, okay, any machine that you start, right, I will not allow anyone to access it. I will not allow. It's like a firewall rule, if you've heard of firewall rules. Okay, I don't want people to, every machine is closed. Machine has 0 ports open. People cannot hit the machine at whatever, app.100xdevs.com:443, let's say, :80, let's say, :3000. By default, Amazon does not allow external traffic access. You have to specify, okay, these are the ports that are open. Everything else is closed. So you can't even SSH into a machine, basically. You can only SSH into a machine if port 22 is open, which is what you describe in a security group. Okay, for this security group, port 3000 and port 22 are open. And every instance that you start, for example, if I look at the EC2 dashboard right now, I have one instance running. Every instance that you start will have an associated security group. And in this security group, you will see the current rules for inbound traffic and also outbound traffic. By default, we open all outbound traffic because it doesn't matter. But inbound traffic is what you control from time to time. Recap. Is it asking for a load balancer template in the auto scaling group? It is asking, why did you create an instance? Did I miss something? Short recap. Yeah, so I'll go from the top. So whenever you want to create an auto scaling group, if this is your final thing that we are creating, what will we finally create? Finally, we will reach this section called the auto scaling group. Whenever you are creating this, it needs a few things. Number one, it needs an image. Here, when I start the machine, what should it look like? Now you can be like, the image would be an Ubuntu image, bro. You can totally start an auto scaling group with a native Ubuntu image, no code on top. But what do we want? We want, here, when the auto scaling group starts, it should start this application with it. So what do? We say, number one, I will create a normal EC2 machine. We created a EC2 machine. And we added our code over here. We added the Node.js library over here. And we created an image from it. We created an image from this EC2 machine. Why? So that we can give this special image to the auto scaling group. Okay, yellow. The code is also here. Node.js is also installed. Of course, there is Ubuntu here as well. So Ubuntu plus code plus Node.js is what we gave to the auto scaling group. Could we have just given Ubuntu? Yes, you can just give Ubuntu. And in your start script of the auto scaling group, you can be like, yeah, I will install Node. Then I will do a git clone. And then I will do an npm install. And then I'll do a npm run start. So you can also do this. If you want to avoid creating your own custom image, you can always just use an Ubuntu image. And in your starter script, what is the starter script? The script that runs when the machine starts is where you can, write all of this code. Or you can be like, yeah, this is my custom image. This already has Ubuntu and the code and the Node.js library. So all I have to finally run, my starter script will be so small. I will simply run npm run start here. Why is this approach better? Because whenever a machine starts, now it doesn't need to install Node.js and get the code. It can simply run npm run start. Maybe one small thing you should add here is you should first do a git pull and then you should do a npm run start. Because when you created the image, you might have some very old code. Now let's say after 100 days, the image is still the same. It still has that old code. So you should first do a git pull so that whenever a new machine starts, it pulls the latest code and then runs npm run start, but it doesn't need to install Node.js again. That is what we're trying to achieve. We're trying to first create an EC2 instance that has my code and the Node.js library, creating an image from it, and then eventually we will give this image to the auto scaling group. Are we good to go now? I think this was decentish recap, but happy to go slower if need be. All right, sounds great. So next up, what have we done? Step 1, created an EC2 instance. Step 2, created an image. I also created a security group that I will finally attach to my auto scaling group. Now I want to create a launch template. What is a launch template? Let's just look at the dashboard and see what all it asks us. Amongst the many things that exist here, there exists launch templates. As the name suggests, this is something you create from which you can launch other instances. But you might ask, Harkirat, images also do the same thing. If I go to AMIs here, now to Harkirat, we created this image. This image has everything. I can just click on launch instance from AMI and I will launch instance. Why do I need a launch template? Why can't I just go to the image and click over here and go from there? The answer is, when you go to the image, I repeat, if you go to AMIs here, click on the image and click on launch instance from AMI, it asks you a bunch of things. It asks you, hey, what is the machine size you need? What is the instance type you need? Hey, what is the key pair that you want to attach to this image? Do you want to create a new security group? Do you want to change the space? I cannot specify all of these in the image, which is where the launch template comes into the picture. The launch template says, create launch. So go to launch templates, click on create launch templates. It says, bro, give me a template. You give me the image also. You tell me the security group also. You tell me the space also, everything you tell me. And I'm going to create a launch template. Now, whoever wants to start an instance, they can start it like this. They don't have to necessarily go through, re-specifying the security group or something else. That is the benefit of a launch template. So this is the third thing we are creating. What did we create? EC2 instance. We created an AMI security group. This is the fourth thing that we are creating now, a launch template. Give the launch template a name. I'm going to call it week 22 launch template. It asks you, what image do you want this template from? And we have a bunch of our own images. You can also select an Ubuntu image, as I said. You can select a raw Ubuntu image, but we have created our custom image. We want to use our custom image over here. So what do? We click on my AMIs and we select the right one. The name of my custom image was week 22 image. What is this? This is the thing that we created in the second step, create an AMI of your image. So that is what I select over here, week 22 image. And then I specify everything else. KR, what is the instance type? Now you can choose to ignore this. KR, nahi, whenever I'm starting the machine, then I will specify if it's a big or a small instance type, or you can attach this in the launch template as well, so that you don't have to specify when you start a machine. Either is fine. I'm just going to leave it. But if you do specify one, then whenever the auto scaling group starts, it knows what to start with. If you don't specify anything here, then in the auto scaling group, you can configure, here I want to start half machines that are T2 medium, half machines that are T2 large, so on and so forth. For now, feel free to ignore, feel free to keep it like this. Key pair. Whenever the machine starts, do you want to allow SSH access using a key pair? The answer is yes. And I will select week 22 AWS class, the key pair that I just created that's present in my downloads over here. Lastly, storage. Defaults are fine, whatever storage it provides you. The volume with 8 GB is more than enough. And lastly, one extra thing. All of this is pretty small, easy, straightforward stuff. Hopefully. This is the image that we want to start the instances from. This might be the instance type if you want to select an instance type. This is the key pair that will be able to connect to the instances. This is the security group. I totally forgot. We also have to select a security group. What did we do in step number 3? We created a security group. We can attach it to the launch instance. What was it called? It was called week 22 class for me. What is this? The security group that we created. If you remember a while back, what did I do? I went to the security group section over here and I created a new security group. I said week 22 class will have port 3000 and port 22 open. I created this security group by clicking on this button and selecting these two inbound rules. I'm attaching this to my instance over here. When I say here the network settings may, I will attach this security group to all the instances that will be created using this launch template. One last thing is left, which is very important, very weird the way AWS does it, and takes a lot of debugging. And the answer is this last section called advanced details, where you put something called the user data. When you hear user data, what do you think user data might mean? This section represents what code should run when the machine starts. That is what user data means. Isn't it weird? It is. The first time I did ASGs 3 years ago, it took me a few days to figure out, acha, user data means here is where I put my starter script. What is my starter script? npm run start, or whatever needs to run once the machine starts. But this is like, number one, very hard to find. Number two, it's very weird the way you have to write it. In fact, I have a gist from years ago, gist.github.com/hkirat, because once I was able to figure this out, I sort of cached it somewhere. I will forget about this. So I was going through this today, so I realized I have this gist from a few years ago. Can't even find it. There you go. This gist right here. Let me also paste it in chat. When was this created? 8 months ago. Probably have more similar gists back in my GitHub. In my GitHub gists. This script, which if you look at it, it's not as easy as pm2 start index.js. It first sets Node.js binary in the path, which if you don't understand, I will explain very soon. Then it sets an environment variable, exports a variable called pm2. Then it exports another variable. Then it does something called su, which means super user, or switch user to Ubuntu, and then run this command as Ubuntu, which also is a very weird command. Okay, first go to some folder, then sets path again, then sets pm2 home again, then runs the pm2 binary, which is this thing right here, then start, then npm, then start. So this is one way for you to one starter script that you can give. If your folder, the application that I was working on was called Stream DRM. It was present on Ubuntu/Stream modules, which was a monorepo /modules/Stream DRM. That's where my code was sort of stored. Today, where is our code stored? If you remember from the instance that we had, our code was stored in week 22. This thing right here. So this week 22 is what I will put here, and this script I was able to arrive at after a lot of trial and error. So if you want to use pm2 with Node, this is one way. I'm sure there's a cleaner script that you can think of as well. But this came after a lot of trial and error. Today, same thing happened. This is the script that I was able to create that will start. This is seems like I used pm2 here as well. So this is probably a cleaner way to do the starter script. But here also, if you look at it, I first had to export Node. Then I've added some debugging statements here. I sort of debugged this for a while because this did not work. If you go to the other launch template that I have right next to it, you will see the one that I was testing with before the class. It has 9 versions. So I tried 9 iterations, after which I was able to arrive at this script, which is the starter script that you can run. Of course, you don't need these echoes, but first export Node.js on the path so that npm is accessible. And then, globally install pm2, go to your folder, and then do a pm2 start index.js. I think this is good enough. I don't think you need these two. This was again for debugging. So pretty sure, you can ignore these as well. So not too difficult, as you can see. but this script is easy because I install PM2 after startup. After the machine starts is when I install PM2. If you had installed PM2 in your image over here itself, is when you might have to go down this route. So either way, I guess you get the idea. This is the starter script. I'm just saying it won't be, if you thought, okay, I will just put cd /week 22 and do an npm run start and it will work. It doesn't work. Or, do whatever. PM2 start, it will not work. Try it out and, you will fail. But yeah, if you want to try it out yourself, debug it, because you'll learn a lot when you debug it. For example, the way to debug it is, find a file in the machine that is started. You can find more details here. But okay, I'll stop there. Either way, this is the starter script. So if I paste the starter script here, that is good enough. This is the last thing I have to do in the launch template. Again, to repeat, what did we do in the launch template? First, we gave it a name. Then we told it, please start with this week 22 image, which has Ubuntu plus Node.js plus your code base. Number 3, we said no instance type directly, attached to the launch template. Whenever I'm starting the machine is when I will tell what the size of the instance would be. Then we gave it a key pair that I recently installed or recently downloaded. I gave it a security group that we had recently created. And I added this user data, which finally starts the code on the machine whenever the machine starts. What does this user data do? It just runs all of these commands that are written here. The first command, putting it in the path, which, you should confirm. I repeat, you should confirm, have you installed version 22? Because this script would change if your machine has a different version of Node.js. So whatever was your original image, whatever was your original EC2 machine from which you created the image, try to go to this folder and make sure this folder actually, exists, because you might have installed Node.js version 21. And if that is the case, then, that is what you have to put there to get Node in the path. So if I go here, yeah, this is fine for me and most probably will be fine for you as well. But, if it isn't, then go to this Node folder and then, find what comes here. And if version 21.0.0 comes, that is what you need over here. If a different version comes, that is what you need over here. What is this specific command? It puts Node on the path, npm on the path. What does putting on the path mean? Basically means whenever the machine starts, it will not have access to npm, because this starter script will probably run before npm is put here on the path, which is why you have to explicitly put it. This starter script runs as soon as the machine starts. And as soon as the machine starts, it does not have access to this npm binary. The another thing that you can do is, wherever you're using npm install, you can also just, use this. Here I will do /bin/npm install. So you can do this as well. Or you can just bring Node.js to the path, which is what this line of code does. All right. Let's do a poll to see where we're at, and then we'll go from there. If you're able to do this, it's pretty smooth ride from here. But are we good to go, guys? Coolish. 82%, pretty decent. Let me just spend, anyways, I think it's time for a break. So let's just spend 3 more minutes looking at Q&A and then we'll go from there. Does not allowing 0.0.0/0 IP to port 20 gives everyone access, but not everyone has your key pair, right? Yes, you should make it restrictive. Either way, you should make it restricted. And how it figures out that 22 needs SSH access and 3000 does not, because both have same settings. Whenever you start a machine, it is by default listening on port 22, and only someone who has a password, has a key pair, can connect to port 22. That is the only thing that's on by default. 3000 pair, whatever is running, we actually started ourselves. We go to the folder week 22 and we started over here, which is why, this is sort of accessible to everyone, because I haven't added a password here. If I add a password over here, or some restriction over here, my website is only accessible to some people, then they will also have to give a password, right? So that's what that means. What is PM2? It's a process manager. It pretty much lets you, start a Node.js application in the background. Yeah, bit confusing. Okay, I'll create some diagrams over here. What is PM2 free plus? Yeah, PM2 we've done in a few classes, but basically I can either do npm run start here, but if I do npm run start here and stop my Mac machine, or this connection disconnects, then this will also exit. So it's generally a good idea to use PM2, which is a process manager, and do like a PM2 start, PM2 start index.js or whatever, which will start it in the background, which means even if I close this terminal, even if I stop my Mac machine over here, it will still keep on running. Is there any preference of operating system to be chosen in case of ASD? No, you can select any, doesn't matter. Whatever your image has is the operating system that will be chosen. My doubt from yesterday. If we have a maximum number of machines in an auto scaling group set to 50 and someone DDoS attacks and it was not able to choke up all the systems, the DDoS is unsuccessful. If someone DDoS attacks, you will, and if they're not able to choke, like auto scale, then yes, choke. Like if they don't have enough, bots to attack the cluster, and 50 machines are good enough to handle all the traffic, then yes. The problem they do is they increase expenses for the companies because the company had to bring up 50 machines. So it's still a problem. You should still have, DDoS protection even before their request reaches your AWS cluster, which means you should have, on the DNS level, DDoS protection, which is something you can do with Cloudflare. We discussed in the Cloudflare class. Is security group type section TCP means allowing HTTP requests, and SSH means you can SSH into the machine? It is TCP for both. If you look at the security group, this is just the name. The protocol is TCP for both of them. So it's a TCP connection on port 3000, TCP connection on port 22. By default, port 22 is listening for SSH connections. This is something you don't even have to start on a machine. Port 3000 is something we deploy an application to, right? On port 3000, we start a Node.js application. So sort of we own this specific application. This by default starts on, an AWS machine. Let's do 4 more minutes, guys, like until 7:15, 8:15 India time, and then we'll proceed. So 4 more minutes. Why are we using PM instead of Node start? I think I answered that. Why can't we use NVM? Why can't we run this code in different Node versions? No, you can run it in different Node versions. Why are we using? I am using NVM because of personal preferences. You can use whatever you want. Doesn't matter. In the end, however you install Node.js, your final node binary will be present in some folder. Whenever you run a command, let's say you run, whatever, Google-chorme. This is one command that starts Google Chrome. This doesn't exist. This isn't a file in this folder. This is a binary somewhere present, right? It's present in some weirdish folder. It's like a shortcut to the actual folder. So what happens when we start, or when this user data executes when the machine starts, is node is not accessible. Node as a command or npm as a command is not accessible, which is why you have to tell the bash session, KR, please find a bunch of binaries here. If you go to this folder, what will you find? If you go to this folder, you will find node, npm, npx. So if you run this command, if you add this folder to your path, it means all of these 4 binaries are now in your path, which means all these 4 binaries you can directly run. So you can now run npm install. But if you don't run this command, then you cannot. Harkirat, then why do you not have to run the same command when you start the machine? When I start this machine, when I SSH into it, then node is automatically added to the path already. But when this user data runs, it runs much before node gets added to the path, which is why you have to explicitly add it. But you can add any other version. You can try this on the free tier, yes, but you might get charged for the load balancer. Just stop it eventually, just stop the resources. It'll be like less than 5 cents. Is it able to block certain IPs? You can. As I said, if you go to the security group, you can specify, okay, what is the source? I have right now said 0.0.0.0/0, which means accessible from anywhere, but you can make it more restrictive if need be. All right. Let's do a quick recap. We'll go from there. What did we do? Number 1, we created an EC2 instance. We added Node.js here. We added the code here. Number 2, we created a image. We called it whatever we call it. And this image now has a snapshot of all of this. Number 3, we created a security group and we said, okay, yeah, this will have port 3000 and port 22 open so we can SSH into our final machines, and we can also have the load balancer discover the services that we're running on this machine. Lastly, we started a launch template. We created a launch template. We haven't created it yet, but we created a launch template where what did we add? We added we attached the security group, which basically means, this thing right here is attached to this. We attach the image, which means this image is also attached to this launch template now. And we give it some user data. What was user data? The script that runs when the AWS machine finally starts. Creating this launch template will not start a machine. It will just create a template from which you can start other machines. Cool. That is what we have done until now. If you click on the create launch template button, which I will now, it will create your launch template. This is where we are currently at. This is what we have done. Can we proceed to the next section? Can we move to the final auto scaling group creation bits? Alrighty. So the next step is probably just creating the auto scaling group. Probably have to create. Yeah, that's fine. Auto scaling group. When you create the auto scaling group, the launch template, it literally tells you, KR, you have created your your launch template. Next steps are you can either launch an instance yourself or create an auto scaling group from your template. It says you have created a template. Amazon EC2 auto scaling helps you maintain application availability and allows you to scale your Amazon EC2 capacity up or down automatically according to the conditions that you define. Beautiful, right? It itself is telling you, okay, bro, there you go. Karo start. You can use auto scaling to help ensure that you are running your desired number of Amazon EC2 machines during demands of spikes and maintain performance and decrease capacity during lulls to reduce costs. Does that make sense? It's literally telling you, yeah, this is the next thing that you should do. So what can you do? You can either click on the create auto scaling group button, or you can go to auto scaling groups over here and then create a fresh auto scaling group. Let's give it a name. What name will we give it? Week 22 class. What's the next thing it asks? Launch template. What is the template from which I will create these machines? And which one will we select? Week 22 launch template, the one that I just created. It asks for one more thing here, version. As I said, your application might change, let's say in the future you add Golang. So you might have to add Golang here, create a fresh image called image2, which has Golang, and then, update your launch template to have this new image2. So you can create multiple versions of a launch template as your application changes. Right now we have a single version, which is why I will just select default. But launch templates give you an option to update them. If I go to my launch template that I just created over here, I can click on actions and modify template. And when you modify template, a new version is created. Now I can select a different image. Let's say the image that has Golang as well. Cool. But by default, version 1 is what we need. Next. Specify instance type attributes. What kind of machines do you need? Do you need them based on some vCPU memory metrics, or do you need them based on some instance types? Either is fine. Instance type is probably the one you should go with, because what is the T2 small? T2 smalls or micros? Sorry, T2 micro. T2 micros are free tier eligible, which means you get 750 hours free for T2 micro. So let's just select T2 micro. Micro machines are fine. They can handle our load. So yeah, this one's free, so feel free to select this. It has a single vCPU, which is fine, and has 1 GB memory, which is also fine. Ignore this. It pretty much lets you, choose between on-demand and spot instances. Spot instances are slightly cheaper, but they're also they go down a lot. Spot instances basically mean instances that are available. Amazon has a very big data center. Some of them are free. So, they're available for cheap, but someone else can actually take them very soon. So they're very unreliable. So you should generally not select spot. On demand is fine. On demand is slightly more expensive, but that's fine. Next, select availability zones and subnets. Availability zones basically mean in the same data center or the same region, they might have multiple availability zones. A lot of time one goes down, so the other one is still available. So you can select multiple here, one here. I can tell you one is better for some use cases, because what will happen is when you create this auto scaling group, it tries to balance the number of instances in various availability zones. So if you have 3 instances started in one availability zone, it will move one of them to the other one. So, you see a bunch of terminations and new machines being created. And for some cases, you don't want terminations, which is why I've seen this in production once. Okay, we created 2 of these. We created the auto scaling group. And then we're seeing here machines are being terminated randomly and, being moved to a different availability zone. And then we realized, it tries to balance it. And hence we just stuck to a single availability zone. Either one is fine though. I'll discuss what that exact use case was when we reach the end of this slide over here. Next, load balancing. Do you want a load balancer attached to it? Yes. Our application is an internet facing application that users will hit. So we do want a load balancer. But are there cases where there is no load balancer needed? Yes. Video transcoders is a classic example of this. If you are creating a YouTube like application, this machine needs to take some MP4 as an input and take out 3 MP4s as an output. It doesn't need to be exposed over the internet via some load balancer. It just needs to do its work. So you don't really need a load balancer in this case. But our case, since it's a HTTP server, we will need a load balancer. A lot of times you don't need a load balancer as well. If your server is running some machine learning algo, it just has to use compute. It does not need to expose a service on the internet. Then you don't need a load balancer. But in our case, we do. So I will attach to a new load balancer. We will create a fresh load balancer basically. Load balancers are of multiple types. We need just the application load balancer. We are writing an application level thing. If you were writing a more low level TCP UDP sort of a thing is when the network load balancer comes into the picture. Rarely do you use it. I've never used it. Application load balancer is what we need. Our application is internet facing. Listeners and routing. Here is where, what is this port 80? I always get confused. This is either the port, this is the port of the load balancer most probably, which means, whenever a request comes to the load balancer, what port are they coming on? And the port is 80 for now. Eventually we will add 443 as well. So I think this should be 80 and it should route to where? It should route to a target group. So we also have to create a new target group, which is, the other thing that we had discussed. What did we discuss? We discussed load balancers. And what did we say? Load balancers are attached to target groups. Load balancers don't know, I am attached to 3 instances. Load balancers know I am attached to a target group. And target group knows I am attached to instances. I repeat, load balancer, if this is a load balancer, when you're creating a load balancer, you attach it to something called a target group. And whenever your auto scaling group eventually starts instances, if these are your 5 instances that are, let's say, created, we need to attach these to this target group over here. So that is how, that's how the flow is sort of expected in AWS. You can't directly tell the load balancer, okay, hey, you go to these machines. You have to tell it, hey, please go to this target group, and you have to attach your instances to the target group. So what is it asking us to do? It is saying, do you want an old target group or do you want me to create a new one? And we will create a new one. Give it whatever name you want. Week 22 class 1 is fine. Ignore health checks, ignore additional settings. Next, group size. How many machines do you need? Let's say we just need 1 for now. Eventually we will auto scale, but for now 1 is fine. Minimum is 1, maximum is fine. 1 desired is fine. 1. We're not changing this setting at all. No scaling policies, no auto scaling up, auto scaling down right now. Just creating the auto scaling group. No policy on instance management, which is fine. How does the machine start? How does the machine end? Should I first start a machine before terminating the other one? Things like these. We don't care. Mixed behavior is fine. Next. We don't need any notifications. Ignore. We don't need any tags. Ignore. Review. To quickly review what have we done. We gave it a launch template. Here we are creating an auto scaling group called week22 class. It needs to be attached to this launch template. It will have this instance type. Oh, we selected 2, which is fine. Like it can either be a micro machine or a small machine. 100% on demand, no spot instances. Is attached to a load balancer, which will forward request to this target group. And auto scaling group also knows, here you have given me a target group na. Whenever I start an instance, I will attach it to this target group, so that the load balancer is forwarding requests here. So this is sort of important. Okay, whatever target group you see here is where the instances will get attached, and that is it. Let me create auto scaling group, and now let me look at Q&A because I feel like there were a few questions. Let's see. Is there any way to automate this whole process? Yes, you can use CLIs or Terraform is exactly this. I'm unsure if I'm pretty sure Terraform should have some, maybe or maybe not, probably should have, a way to create auto scaling, all of this. Yes, but yes, there is definitely a CLI that lets you do it. So you don't have to go through all of these steps. And that is also a good idea because, if you ever want to move AWS accounts, then you can simply run a few commands. Why is it taking 8 GB in image and security groups? It is not, it took 8 GB in the SSD, which means how much space it needs. How do you group EC2 instances? Is it done by AWS? How do it under the hood make a single target group? Yes. So when you create the auto scaling group, we created which one? Let's create a new target group. We anyways have to do that because our current target group will be slightly incorrect. But maybe before that, should we see if it's working? Let me just see let's see if it works or not, and then let's do some more Q&A and fix a few things that are broken. Let me quickly revise. What have we done? Created EC2 instance, created AMI, created security group, created launch template, and lastly we created an auto scaling group. When we were creating it, we selected a few things, specifically attached the launch template that we had, created a new load balancer, and created a new target group. And lastly, the auto scaling group was created. If I open the auto scaling group now and see instances, you will see there is one instance that is currently running. If I go to this instance, copy the URL and try to hit URL:3000, it says nothing is working. No, it is working. There you go. It started. So it says hello world over here, which means seems like it worked. We'll have to see if it works behind a load balancer. But all of the mehnat that we did, all the effort that we put in, seems like it is working. If you want to ignore the auto scaling group creation, you can do that as well. You can be like, take care, I have the launch template. From this launch template, I will create my own machines. I will click on actions, launch instance from template. So you don't have to use an auto scaling group if you have a launch template. You can create your own instances, or you can attach it to an auto scaling group. Why? Because if you have an auto scaling group like we do over here, I can just increase the number of machines to, whatever, 4 over here, and it will create 4 machines for me automatically. All 4 of them will have something exposed on port 3000 like this one, and they can be accessed on the internet. The problem still remains that we are not accessing it via a load balancer, but we can fix that very soon. Now let me look at Q&A for a few minutes, and then we will proceed to the load balancer bit. ASG first run launch template, then image. ASG first, what does that mean? I don't understand what that means. Is there a way to terminate EC2 instances created directly if say our bill is now more than $50? Budget alerts, there should be budget alerts in the dashboard somewhere. A pretty cost management section will probably have some sort of budget alerts. Okay, if it goes over $50, send me an email. How will you deploy new version of the application on the ASG? Yes, so as I said, you can do a git pull in your user app, whatever is your user data, along with setting the path variable. And before you do npm run start, you can do cd week 22, then you can do a git pull, and then you can do an npm run start, or maybe even npm install, because you might have new dependencies from the git pull, and then do an npm run start. Is the target group similar to resource group? What is a resource group? If don't attach load balancer transcoding use case, what will be the point of auto scaling? How will it know which EC2 instance to send the request from? You are not sending a request in case of a transcoder. If you have multiple machines that are started, these machines pick up requests from a queue. There is a queue and these machines pick up requests from here. So they sort of pull the data from here to here. No one calls an API endpoint on them, hey, you should start this. They pick it up themselves. And so basically the arrow should be the other way. They hit a queue and ask, hey, is there something I can do for you? And then the queue is like, yes, there you go. Since outbound traffic is allowed, they can still ask the queue for the next row. So that's why they don't need to be internet facing. I am naive in AWS. How can I try all this without getting unduly charged? So you can, if you want to try all this without getting unduly charged, use something called Elastic Beanstalk, which will, number one, make it very easy to do this. Number two, you just have to delete one thing, which is the Elastic Beanstalk application, and it'll clean up all of your resources. That's a call out I've made probably in the end. Okay, try using Elastic Beanstalk. It gives you the same benefits without the developer having to create all of these. So the effort that we went through, we actually don't have to do any of that. If you use Elastic Beanstalk, it creates all of these for you, a launch template, an image, an auto scaling group. And when you delete the Elastic Beanstalk application, it cleans it up for you as well. So that's the easier way to do everything that we have done right now. What if you have an ML model? Then what script we might have to write? Whatever is your whatever starts your Python process, right? The script is basically, the starter script is basically whatever starts your application, or whatever your application is. You'll do a Python a.py, or go build or go run based on whatever application you're running. If it's a Golang application, you'll run the binary. If it's a Python application, you'll run Python a.py. Can there be multiple target groups to which the load balancer can send? Yes, you can have multiple target groups. You can also be like, here, load balancer, send the first target group 50% of the time, send the second target group 30% of the time, so on and so forth. What's the benefit of creating an image and having multiple snapshots of an EC2 machine? We don't have multiple snapshots, we just have one. And the benefit was, your EC2 machine, the image that we're creating will have not just Ubuntu, but also Node.js, also NPM, also your code. This is all in the same place for you that you can just start from. I have an application called BlogX in Golang. I have a Docker compose in EC2 inside BlogX folder. So in launch template, this thing should work. I have added the Docker user to user group, and hence don't need to use sudo. Currently on EC2 instance, Docker compose works well. Nice. Yeah, that probably might work. How will you deploy new? Okay, answer that. Okay, let's do a poll, and if the poll does decently well, then we will proceed. This is one thing left, like two things left. The load balancer bit, and then attaching a certificate and your own domain name to the thing, and then you're good to go. Alrighty, this is good enough, 86%. So let's quickly see, does the load balancer work, or have we missed something? Let's go to, when we created this, it also gave us the option to create a load balancer. We did. So let's go to the load balancers here, and you might see one or two over here. The one that we are focused on is week 22 class. If you look at it, you will have a URL that you can go through. This is your load balancer URL. This is your, this thing right here, the URL that your end users are supposed to hit. This load balancer URL for me is this. We will see eventually how this can become, app.100xsteps.com, how you can bring it to your own domain name. But for now, it is this. Let's see if it works. If I go here, the request remains hung for a long time. That shouldn't have happened unless. Oh, not reachable. There you go. The security group for your load balancer doesn't allow traffic on this listener port. Manage your security group in securities tab. I would have assumed we added this somewhere, but okay. There is a new security group created for our load balancer as well. Here also, let's add inbound rules. What ports do we want open on our load balancer? People will either send requests on port 80, which is the HTTP port, or port 443, which is the HTTPS port. So what do I have to add here? Edit inbound rules. I need to add a 443 and a port 80 Anywhere IPv4, anywhere IPv4. Save changes. Now if I refresh the load balancer, you will see the warning went away. Now if I go to this load balancer URL, it still says 502 bad gateway. Why is it not working, Harkirat? You created a load balancer. You have an auto scaling group which currently has 4 machines running. Why is my load balancer not able to send requests there? Let's try to debug it. Week 22 class 1 sends requests to what target group? What was the target group that we were sending requests to? Any request that's coming on port 80 should go to week 22 class, this target group. If I open this target group, what does it say? It says 0 healthy, 4 unhealthy. So our 4 instances are attached to this target group. If you look at it, I have 4 instances here and 4 of them are attached, but they're all unhealthy. Why? Because the port they're trying to hit is port 80. And where is our application running over there? It's running on port 443. So we can not edit this. We probably have to create a new one. So we will create a new target group unless someone knows how to edit it. Seems like you cannot edit this though. So let's just create a fresh target group and update our load balancer to point to the fresh target group. What will I do? I will go to the target groups here. I will click on create target group and I will attach it to instances is fine for now. Eventually we will give it to auto scaling group, so it will be able to attach all the instances here. The only thing is what port is our application running on? Not 80, it is running on port 3000. Everything else is fine. Target group name, week 20 target group 2. So what am I doing? Creating a fresh target group with the right port address. The port address on the other one was incorrect. Next. It's asking me, do you want to attach any instances to this target group? I'm not going to. I will give it to the auto scaling group. It will automatically attach them. Create target group. Now I have a fresh target group with 0 instances because I've attached no instances to it. How can I tell the auto scaling group, KR, now you are supposed to attach all the instances here? You can go to the auto scaling group. Week 22 class. Click on edit over here. There you go. In load balancing, click on edit and change the target group to be, whatever is the target group that you just created. One not load balance, that's fine. We will eventually associate this to the load balancer as well. It is giving you a warning, but that is fine. What did I do? I have now attached this auto scaling group to my newly created target group, which means all of my instances here will now go to the newly created target group. If I now refresh this, wait for a while, this will become like 4 and 0, and now all 4 of them will be healthy because the port we have changed to 3000 where the application is actually running. Hoping this is straightforward. There are a lot of things, so I also won't be surprised if you got confused a lot, but I will recap everything after we're done with this. There you go. 4 of the instances came over here. It's still trying to send them a health check, but once this health check succeeds is when we'll see 4 healthy over here, hopefully, because all 4 of them have something running on port 3000. If I go to the auto scaling group and open any one of these 4 instances, you will see something is running on port 3000 over there. Cool. Let's refresh. This will eventually happen. Let's go to the load balancer and change the target group over there as well. What was the problem with our load balancer until now? The problem was that this load balancer was pointing to a target group which was pointing to the wrong port on our instances. So we created a new target group with the right port. We attached it to our auto scaling group, and now we're going to edit this specific listener. What is a listener? Here, any request that's coming on port 80 to the load balancer, where should it go? Currently it says week 22 class. We are going to change this to be week 20 target group 2. This is the new target group that we had created. we're going to send all requests here. And for someone who asked, can you add multiple target groups here? Yes, you can add another one. And you can specify what's the weight of each of them, and load will get balanced that way. Alrighty. That should be it, guys. I think that should do it. Now our application should be available on the load balancer URL. If I copy this, paste it here, hello world works, which means, I have a load balancer which is sending requests to the instances. Did we understand this last part, or should I recap? Are we good to go? Can I proceed? No, last part was a little too difficult, which is why we will recap. What was the problem when we created the launch template? We did, from the top, we did 4 things. Created an EC2 instance, then created an image, then created a security group, then created a launch template. Now, when we were creating our final auto scaling group, we did a problem. What problem did we do? We said, hey, please create a new load balancer which will point to this specific target group. So create a new target group as well. But we did not specify that the target group should check the health of an instance on port 3000. The original target group that got created for us by default, if you look at it, the target group that was created for us by default, which was this one right here, it was trying to access port 80. Why is nothing happening on the instances port 80? Everything was unhealthy. If you remember, it said 4 unhealthy over here. Why was that? Because it was trying to hit our instances on port 80, but nothing was running on port 80. The process was running on port 3000, which is why we had to get rid of this target group and create a new one. So what did I do? I went to this target groups section, and I can delete this one if I want. But what did I do? I went to target groups and I created a fresh one. I created a fresh target group, which is this one right here. And over there I said, bro, port 3000 is where the application is running. This health that you are checking of all of my instances, right? Please check if something is running on port 3000 there, not port 80. Because if you check on port 80, nothing is running there. So I just changed this, created a new target group with port 3000. Then what did I do? After this step, I created a new target group pointing to port 3000. These are all the steps from the beginning. Then I told my auto scaling group. Originally, my auto scaling group was putting all my instances here on the wrong target group. So I told it, hey, please update the target group to be this new one right here. I have just created a fresh target group. All the instances that you have should connect to the freshly created target group. Please forget the original target group that was created. And lastly, I went to the load balancer again and said, hey, you will route all requests. You will route all requests that are coming on port 80 to the newly created target group. I pretty much deleted this pointing that it had. It was originally pointing to this target group. I said, no, sorry. Any request that's coming to you will go to this newly created target group. How did I do that? How did I do this step of changing the auto scaling group's target group? I went to auto scaling group here, selected node app one, the other one, and then clicked on edit over here in load balancing and changed this target group. And what was the next step? The last step, I changed the load balancer target group, which I did by going here, followed by, load balancer, followed by this section represents, okay, what are the listeners on this load balancer. Currently, we have a single listener on port 80, which forwards requests to this target group. So I said, I'm going to edit this. I'm going to edit this rule and change the target group to be the new target group that I had created. What did I do? I connected this load balancer to the freshly created target group, which has the right port for the health checks. Now, if I click on save, everything worked, and the load balancer sort of is able to route requests. But do we understand what I did in the last few steps now? This was the whole history. Ideally, when I was creating the auto scaling group is when I should have been able to specify that the target group needs to point to port 3000, or I should have created the target group first and then attach the target group over here. When I was creating the auto scaling group, I did not specify the final port. Maybe you can't even do this. There's no way to specify the target. It just assumes it's port 80. So that is why I had to create a fresh target group. Do we now understand why I had to create a fresh target group? And if you do this, you also have to attach it to the auto scaling group. You also have to attach it to the load balancer. So those are the next two steps that I did after I created the target group. Do we understand what I did in the last few steps now? Oh, okay. That sounds pretty good. 92% is great. What's left? Only one thing, Harkirat. If you could tell me, Harkirat, how can I point this to my own domain name? Then it would be very nice. And the answer there is, thankfully, it's very straightforward. This is true irrespective of how you have a load balancer and an instance. You don't necessarily have load balancers only for auto scaling groups. You can, create 5 EC2 machines yourself and attach them to a load balancer. Either way, the thing you have to do is go to your load balancer, select the one that you want to attach to your own domain, which in my case is, this one right here, and add a listener on port. Can you guess? Port 443. Port 443 is the port that listens to HTTPS, right? So I'll add a listener. I will say the port that you're listening on is HTTPS, which is 443. And it will forward the request to what target group again? The freshly created target group, which is week 20 target group 2. But whenever you have HTTPS connections, if you remember, you need a certificate attached. You need a certificate for your domain, which we used certbot for in the past. But today, we're going to use AWS's certificate manager. You can also use certbot and store it somewhere here yourself. But AWS has its own certificate manager, and it's a good idea for you to use that for 2 reasons. One, it is more authentic than certbot. 2, it will automatically renew your certificate. It will automatically tell you, hey, your certificate is expiring. Let me refresh, renew it, so on and so forth. Certbot doesn't do that. In certbot, you have to sort of keep renewing your certificate from time to time manually. So if you look at the secure listener settings, it will say, hey, do you have a certificate for this? And you will most probably see nothing. I have one already because I already created this once, but you will have no certificate. So you will have to generate a certificate for your domain name. What are you trying to do? You are trying to attach your own domain name to the load balancer. Before you do that, you have to create a certificate for your domain name. So you can request a new ACM certificate. This is similar to when we were running certbot on the terminal. We were trying to create a certificate directly on our machine. This is us asking AWS, please create a certificate for us. I own the domain. class.100xdevs.com is owned by Harkirat. Please give me the certificate. I will prove to you that I own it, but please give me the certificate. So the question is, how can you prove to AWS that you own the domain name in the first place? And the answer is, when you click on next and you tell it your domain name, hey, I want a certificate for, class week 22.100xdevs.com. This is what I want a domain name for. It gives you 2 options to pretty much, verify that you own this domain name. DNS validation is the easiest one. And, any key algorithm here is fine. Request. And when you do that, if you refresh the page, you will see I have 2 certificates. One is issued already. Other one is pending validation. I need to prove to AWS that I own this specific domain name. Class week22.100xdevs.com. So if you go here, it will pretty much give you, please add these DNS entries. This thing should point to this domain name. If it does, then I will assume you have proved to me that you own the domain. So what will I have to do? I will have to add these values to my DNS provider. What is a DNS provider? Where you buy your domain from, not a domain name provider, I guess. Yes. So if I go to domains.google.com, where my where I buy domains from. You might buy it from Squarespace or GoDaddy, doesn't matter. These are all the domains I own. If I click on 100xdevs.com, click on manage, select DNS on the left and click on manage custom records. Here I have to add the record that they've asked me to, which is, okay, hey, you add a CNAME record, which means type is going to be CNAME for what is the URL, underscore some long hash basically, dot classweek22.100xdevs.com, which means this is going to be my key for the domain. If I type this over here, what is the final domain this is pointing to? Whatever this prefix is, .100xdevs.com. And where should this point? It should point over here. Why am I doing this? To prove to AWS, Kiara, I own it. You asked me to put this, yellow, I've put it. That is how I prove to AWS that I indeed own this domain. And then AWS is like, sure, I will issue you a certificate. You have proved to me that you do indeed own this specific domain. Now, if you refresh after some time, this certificate will also get issued. Currently, it's pending validation. But if you wait for like 2 minutes, the certificate will get issued. And from there, it's pretty smooth ride. Let's just wait for this to happen though. We'll look at Q&A until then. Are AWS certificates also free? Yes, I think. I don't know. Maybe not. You should Google. I don't know. Maybe they're probably not free actually. How load balancer device requests? Well, this depends on how AWS does it. Like, we don't have access to the logic that they use. I would assume it's a load balancer. So it either round robins, for example, first sends it to the first machine, then to the second machine, or checks the actual load and sends it. So it really depends on how AWS has implemented it. Could you please let me know if you have installed PM2 and started the node process? Where? In the machines? Yes, we have. If you remember the user data that we had put, what was the user data that we put? It was this. This was the user data that we put. So if you do put this user data, as you can see, we are installing PM2 here. Let's see if the certificate is issued. And it indeed is, which means I can go back here and I can refresh the certificates. No, target group is fine, sorry. Sorry, this is the wrong tab. There you go. This was the tab where I was trying to add a new listener. I said, on port 443, I want you to forward to this new target group. And here is the certificate for my domain name. My domain name is classweek22.100xdevs.com. Here is the certificate for it. And add. Now, can you guess the last thing I have to do? I still have to go here and add one more record. This record that I added, the one that you saw a while back, was for proving to AWS. I can delete that record. That's not needed anymore. What is needed is this actual domain, which is, what was it called? Totally forgot. Class 12. Class-week-22.100xdevs.com. I need to add the record for the actual domain, not for proving to AWS, but for the real thing. So if I put this here, I again need to select a CNAME record here, and the value is going to be the same thing that you see over here, this DNS pretty much. So if I paste this DNS, click on save. That's the last thing you have to do, and you have a application running. Or slash deployed on your own domain name. If I now go to week, whatever the domain was, week-20, this domain, I have added a CNAME entry which points to this specific load balancer URL. If I go to the load balancer URL on port 80, I see it working. If I go to my class URL on port 80 or 443 either, it will still work. As you can see, it's working on port 443 HTTPS. And if I go to the certificates, the certificate is issued by Amazon now. The thing that we sort of did when we were here in the certificate manager. I now have sort of a certificate that's created by Amazon, very similar to how we were creating one in using certbot. It still has the private key, PEM key, things like these. it just, has all my AWS services can directly access it, which is, cleaner than using certbot. All right, did we understand this part? Because it's just a bunch of experiments on auto scaling, and then we'll try to call it. Wow, it's almost been 2 hours. Can't believe it took so long, because it's like usually pretty straightforward-ish, but maybe not. Okay, pretty good. So we understand how to attach our own certificate. The last experiment, if you want to run, is an auto scaling group, but we haven't done any auto scaling yet, Harkirat. You have done scaling. You have not done auto scaling, Harkirat. You selected 4 and you kept it at 4. How does it auto scale? How does it go up and down? So I'm quickly going to run a few experiments, and then you can try them later in your own time. I'm going to set minimum to be 1, maximum to be 5, and desired capacity to be 1. So it will downscale to a single machine, which is fine. If we go to instance management now, you will see I have 4, but 3 of them are terminating. Only 1 of them is in service. If I go to the URL, still works. Or even the load balancer URL will work. The problem is, how do I auto scale? And the answer is there's a automatic scaling section over here, where you can add the easy policies. What were the easy policies, if you remember? KR CPU usage. If CPU usage above something, do something. If it downscale. So you can create a new dynamic scaling policy. KR target tracking scaling. There are a bunch of types here. Step scaling is a little complicated. Feel free to read about it. This is the easiest one. Average CPU utilization should be 50%. If it goes above it, please increase the number of servers. If it goes below it, please decrease it. This is the easiest way to create the most basic auto scaling policy that just works. Because most use cases won't be very tough. What will you deploy? A simple full stack application, backend for a Paytm application. As the load increases, the auto scaling group will automatically scale up. It will try to ensure that the average CPU usage is 50%. If it goes down to 20%, it will downscale as well. So all you have to do is attach or create a dynamic scaling policy. And now, what is my minimum? 1. What is my maximum? 5. If my CPU usage goes up the roof now, if I go to my instance that is currently running, so still I only have 1 machine. I've added the auto scaling policy, but since no one's hitting my machine, the CPU usage is pretty much 0, right? So it would not auto scale up unless I go to this machine, and start a very CPU intensive request over here, process over here. If I open an index.js file here, where I write this code, let I equal to 1, while 1, I++. Let's say I write this code and run this code on the machine. What is the code? An infinite while loop. If I run node index.js, what will happen? The CPU usage of this machine will become really high. If I go and SSH into the machine again, SSH-I week 22. And look at the CPU usage. You will see the CPU usage is now 100%. This is a simulated CPU usage spike. Of course, real users are not hitting your service, and the CPU isn't going up because of that. I'm just simulating. If the CPU usage does become really high, does the thing auto scale up? We will see very soon. And I hope you get the idea. I'm just simulating the CPU usage going up. Even if a lot of users visit the website, this CPU usage will go up then as well. And when it does, we need it to auto scale. So we're just simulating the same thing, but the same thing would happen if we have a lot of traffic. So the final outcome of scaling up should still happen either way. Let's look at the slides. Auto scaling part, we understand we can add various types of policies. This is the easiest one. Then try to play with min and maxes. We've decrease them, increase them. You'll see number of instances go up and down. Simulate a scale up. That's what we're doing right now. We created this infinite while loop in one of the servers. We saw that the server usage is really high. Let's see if it scales up or not. I mean, spoiler alert, it will. I already tried it before the class, right? There is an activity section here in the auto scaling group where you can pretty much track everything. So if you go to week 22 class and click on activity, it'll pretty much tell you whenever, the number goes up from 1 to 2 or 2 to 3 or 3 to 4. So you can track all of that here. Eventually you will see something like this. Okay, an alarm was triggered, which led to the capacity going from 1 to 2. And same thing will happen if I, stop this process, then it will go back from 2 to 1, it will downscale. Last thing I want to discuss, we'll see the auto scaling very soon, but last thing I want to discuss quickly was, okay, if you remember, I told you there are ad hoc ways of scaling as well. A lot of times the metric that you want is not CPU usage, but some other random metric. Yeah, I need 5 servers right now because my queue length is 3, or I need 100 servers right now because of some metric that you have decided yourself. The two types of sort of things we discussed here. If you're creating a chess-like application, then this final number, if the number of people that you have is 80,000, you need 80,000 WebSocket connections, then you probably need 10 servers. So the metric is something you own in this case. Here, I want 10 machines because I have 80,000 users. So if you have an architecture like this, how can you tell the auto scaling group, KR, please increase the size to 20 machines or 30 machines? And the answer is you can write a process in Node.js, in Golang, whatever language you want, that connects to the auto scaling group and just tells it, hey, please increase the capacity, please decrease the capacity. The code in Node.js looks something like this. If you look at it, it's less than 10 lines of code or 20 lines of code. AWS has something called the AWS SDK. It has it in Golang as well. It has it in Rust as well. It has it in CLI form as well. So, you can send a request to AWS from various places, as long as you, of course, have some secret password to your account. So the first thing you have to do before you write any of this code is to create a new user in this section called security credentials. So you can go to this section called security credentials in AWS and create a new user that has some restricted permissions. You can ideally create these access keys and secrets for your own user as well. So what do you need in the end? You need an access key and a secret to connect to your auto scaling group and change things there, change the desired capacity. But you shouldn't do it for your own user. You should create a fresh user which has restricted permissions and use the access key and secret for that. If that user account gets compromised, only your auto scaling group gets compromised, not the whole thing. So you can go to this section called security credentials, click on users, create a new user. For example, I've created a user called autoscaler, and this user has, if you look at the permissions, it only has one permission: auto scaling full access. It has full access to my auto scaling group, but nothing else. So it can't create images in S3. It can't delete my images from S3, things like these. And why is this good? Because, even if the credentials for this guy, which, are present here, if you click on security credentials, you can, create a fresh access key over here. I already have one that I created sort of 4 hours ago to try this out, but even create a fresh one. After you've created the user, you create an access key. This will give you the access key and password that you need here. And then, you can pretty much do anything you want in your auto scaling group. For example, you create a new instance of auto scaling by calling aws.autoscaling, and then you call a function called update desired capacity that you've defined here. You've defined a function called update desired capacity. We call it with 2 arguments. Okay, this is the auto scaling group that I now need to scale up or scale down. What are our auto scaling groups called right now? We have 2. One that I created before the class, which is node app1. Now we have a new one called week22 class. So I would probably replace this with week22 class. And the desired capacity. This number depends on you. It might come from your number of active users. It might come from your queue length if you're creating a YouTube transcoder service, whatever. And you can pretty much just call autoscaling.set desired capacity, and that will just set the desired capacity. I tested it before the class, it works. I built a very big sort of transcoding system, pretty much following this architecture. It works pretty well. It worked for a year almost before, it was moved off to something else. But yeah, so this Node.js process pretty much, sets the desired capacity. The use case that I'm talking about that I made was very similar to YouTube. So, you would scale up based on a queue length, then scale down, so on and so forth. So yeah, if you write this code, you can do ad hoc scaling as well. If you don't want to offload the scaling to AWS, or you can just offload it by CPU usage is above a number, you do something. All right. Cool, that's all. Let's see if our server scaled up. If I go here now to week22 class, it's still at 1. Oh, there you go. Can you see the desired capacity went up? If I go to activity and sort it by time, Yeah, what I was saying was, if you look at it, an alarm went off because under the hood this creates a monitoring system which is monitoring your CPU usage and has an alarm, and when the alarm goes off it notifies the system, and then that is what scaled it up from 1 to 2. I did not manually do it. If I stop the while loop that I had running, if I stop this right here and this CPU usage goes down to 0, and then of course the other machine also has 0 usage right now, no one's using our application, it will scale down to 1 as well. Cool. Do we understand this? Are we good to go? The last thing that's left is cleaning up the resources, which we should very aggressively. So, but let me just check first. Are we good to go? Last thing I'll do is clean up the resources, then I'll do questions. Alrighty, good to go. So let me quickly clean up resources now, and you should do the same. The easiest thing you can do is first of all just make the desired capacity everything 0. This will take away most of your costs because your instances are not running anymore, but you're still being charged for your load balancer. You're still being charged for the images that you created, so you have to clean up everything. So I would number 1, delete the auto scaling groups completely. Delete 2, and when you delete them, if they had any instances currently running, they will automatically get deleted as well. What is the next thing you should delete? Probably the load balancers. I have 2 of them. Load balancers get expensive very quickly, so yeah, delete them. Everything else isn't like a lot of money, but these 2 resources are expensive. The actual instances and the load balancers. Then the target group, I don't know if you get charged for this, probably don't, but still delete them. Then the launch templates. I don't think you get charged for these either, but I could be wrong. I think you cannot delete an image if it's associated to a launch template. So you first have to delete all of your launch templates. And then lastly, go to images or AMIs and delete them as well. Deregister. There you go. And then go to the EC2 dashboard. You will still have 1 machine. If you remember, we had originally created an EC2 machine. If you remember the steps that we took, the very first step was creating an EC2 machine. We totally forgot to stop it. After you have created the image, you no longer need this. You already have the snapshot of the machine. So we should have just stopped this initially itself. But let me just stop it now. Click on terminate so that you don't get charged for it at all. Alrighty. I think I've released all the resources. I could be wrong. But yeah, I think this is like pretty much. Yeah, check your AWS dashboard in 5 days. If you have some charge, then you have something missing. Opening up for Q&A, guys. Long session. Alrighty, starting from the bottom. Like we have mentioned everywhere, and so like we have mentioned port everywhere. And if the port changes in the code, then I have to change port everywhere. Yes. If the port changes in your code, you have to change the port everywhere. Not everywhere, but like in your target group, right? Your target group was the only place that was using your application port. So that's the only place you have to change it. Suppose like the OTP brute force thingy, we set a loop that keeps hitting the service. We'll get an auto scale. We will. That's something someone asked yesterday. Okay, what if you have a DDoS attack and you have a maximum capacity of 50? You will scale up. There's not, unless you have, that is why you have the DDoS protection. When you add DDoS protection, if you've added it via Cloudflare, let's say, the request won't even reach your servers. So it will not reach your load balancer only. It will get stopped by Cloudflare pehle. So, that is why you will not scale up. But if you don't have DDoS protection, yes, you will scale up. Like we're sending, I get it. If you do that, if someone sends a lot of requests, yes, of course it will scale up. If we change something in our Git repo after auto scaling is up, how do we update it in our instances in the CI/CD pipeline? Great question. So what you can do is, whenever you do this, okay, you have made a push on GitHub, I delete this. You can pretty much decrease the capacity to 0 and then decrease it back to 1 or something. You basically take it down to 0 once, so that all of your old instances drain, all of your new instances start. And in your user data, if you remember, I said add a git pull the data, pull the latest code from Git from time to time. So that's how you do auto deploy. So in your CI/CD pipeline, add another sort of thingy which will take your auto scaling group down to 0. Yeah. Alrighty. How data get duplicated when Postgres instance count is increased by autoscaling? Oh, you don't do autoscaling in a Postgres instance. No. Databases, no. You do use this for an application, bro. If you are doing databases yourself, which in itself you shouldn't do, you should use RDS, you should use NeonDB, whatever. But in this, any auto scaling databases separate. Never do database on container auto scaling, EC2 auto scaling. Never. How often should AMI snapshot be taken? Oh, only once, right? Only once if you're having a Git pull. If you don't have a Git pull, then you can keep creating images again and again. Does the Elastic Beanstalk replace all the work we did for HCL? It replaces all the work, as in it does everything under the hood. If you use Elastic Beanstalk, then all you have to do is give it a Node.js application. Whenever you use Elastic Beanstalk, you can create an application here and you give it some Node.js code. It will create your image, create your auto scaling group, create your launch template, create your load balancer, everything. So you don't have to write a lot of that. And the second benefit is you delete your application here, it deletes everything for you. Under the hood, it still uses the same things. All the things that we've learned today, auto scaling group, Elastic Beanstalk will do all of it for you in one go. In load balancer, you can add resource map in new tab to see the flow of requests. Nice. PR review reminder. Let me bookmark this. Someone asked Jakarta or Hanoi. Question. I'm in Vietnam. If you've stuck all for so bad, I think you should know this. Usually, at what point does a website need to scale and how much? Can you give some breakpoint for scaling according to with machine number of users? Number of users is a vain metric. You might have an application a trading application where people are sending requests. You might have a simple chess application where people send requests, to one request a minute. So it's more about your CPU usage, less about the number of users. You might have just 10 users who blow up your CPU, and when they do, you should auto scale. You might have million users that send one request every 5 minutes, so you don't need to scale beyond a single instance. So it depends more on how much CPU usage gets used based on the current usage, and based on that you scale up or down. Echo की जगह source.bash कर सकते हो your data पे. You mean rather than adding the path, I could have sourced the bash RC? Yes, that might have worked, might not have worked. I haven't tried, but yeah, sounds right. Port 80 is default for HTTP to get web page the first time through GET. Yes. What does that mean? It is when you go to a web page, it does hit port 80. Yes. Was that a question, or was that you telling me that? Usually at what? Okay, answered that. How load balancer divides request is something AWS knows. There are a few policies, right? For example, round robin is the famous one. Okay, round robin means I will first send first to first server, second request to second server, third to third server, then again to first server, second server, third server, like this. Or it could be based on load on the machines, because it's a load balancer. So you should probably balance the load, right? If there's a single machine at 50% CPU, you should send the request to the other two. So you'll probably have to read how does AWS does it, if they have Let me start recording. Hello, mic testing. Sorry about that. I was saying, serverless and this are very different things. You don't worry about auto scaling in serverless. Cloudflare does. You just tell it, this is my code. If 1 million people come, their request should be handled, and then they handle how to auto scale up and down. Which is the best cost effective in terms of pros and cons? Cost effective when you have less users is serverless. Cost effective when you have more users by a margin is owning your own infrastructure, which means having your own machines and auto scaling the way we did today. How to do load testing to check if the setup is not working on? There are a bunch of libraries that let you send 1,000 requests together, so you can use them. Load test is one such library that you can, in a single command, send 1,000 requests to a server, and then keep sending it again and again, and that's what you can decide. Okay. Time for some Notion docs, then we'll call it, guys. Why are we using NVM? Can't we run with different node versions? I mean, you can. NVM lets you change versions as well. If you do a NVM install version 20, it will install version 20. You can install Node.js however you want. You don't have to use NVM. That's just my preferred choice. You added inbound tools using IPv4. What is some? Then you should add for IPv6 as well. I knew I was on IPv4 today, so I sort of used it. But sure, you should add rules for both IPv4 and IPv6. I initially thought image means Docker image and push it to Elastic Container Registry. No. So I hope you get the idea. It's different from Docker images. I guess ASG is the harder way. Kubernetes is the best approach. We will see, sir. We haven't reached Kubernetes yet. Kubernetes is also very complicated. This is actually easier for if you don't want to get into containers and want to do a simple application that deploy. Especially if you use Elastic Beanstalk, you pretty much get the benefits of what we have done today without doing any of the effort we have done today. So we will see. You feel like this Kubernetes is better? I'm telling you, we will see when we reach there. And you might be thinking a little ahead already. Kubernetes is not easy until it's a long learning curve. It's like TypeScript, long learning curve, but eventually gives you benefits. It's like Rust, long learning curve gives you a lot of benefits. Same for this thing. All right. With respect to Postgres autoscaling, I want to know how RDS manages data duplication if we have multiple instances. I'm pretty sure even they don't autoscale. They also ask you when they create instances, and then if you ever want to scale, they're like, okay, let me start another worker, which will probably be either a replica, read replica, or just slave to a master slave architecture, and then it doesn't auto scale it. I guess so you can auto scale read replicas as long as your main machine isn't getting like spun down for whatever reason. But yeah, I don't know how RDS does it. So that like NeonDB is serverless, right? It pretty much means it does not tell you what instances it's running on, and it's supposed to at least theoretically handle a lot of load. If the load increases, they should be able to scale up. So how would they do it? I have no idea. But yeah, I would assume from time to time they would scale up the main master, and then if they feel like, because most applications are read heavy, they would probably have read replicas is what I would assume. So we're planning to cover AWS CloudFormation, AWS CDK with Server DB setup, and AWS to be created programmatically. AWS to be created programmatically, we might not. CloudFormation, we might not. I don't know what CDK is. So pretty much seems like most of the things we won't. We'll probably we'll jump directly to EKS or Kubernetes because it'll work the same for any cloud. But if you want, and there are some AWS constructs we have to talk about, like S3 and CloudFront. So we can take it up, but it depends on how it will not be prioritized for sure. Can we practice container auto scaling as well? What do you mean practice? We will learn about it eventually when we reach Kubernetes. But yeah. Follow-up question: is the target group a conceptual logical? It is a logical concept for a couple of machines. Now, in this case, our target group attaches everything in the auto scaling group. But you can create your own target group, attach 3 machines of yours. Yeah, it's a logical concept. Basically, you're right. Cool. With that, let's call it, guys. I cannot believe the class went for a decently long time today. So I'm not feeling well, but this is a good class. We will do database in offline videos next, and then we'll go from there. I will take last set of questions. Some questions are pending, Akash says, and another Notion doc that I have missed. So Akash's Notion doc, and then another Notion doc, and then we'll call it. Akash says some questions are pending. Oh, off-topic questions from a friend. Is Mun good enough for remote job? Okay, these are off-topic, but oh no, something more. Previous topic. I deployed backend on Render and added course URL for frontend using env, but I'm still able to ping server using Postman Chrome browser. How is that possible? Oh, great question. Added course for frontend. That's the thing. Course is a concept. What does it say? Cross origin resource sharing. If you send a request from Postman, you are not sending it from an origin. You probably don't understand course then. Do you understand why course was Do you understand why course was introduced? Course was because what were people doing? If you come to myhackywebsite.com, I could send a request. If I'm the developer of this website, I could write code like this: axios.post hdfcbank.com/transfer to Harkirat. I could write code like this. I can write Meri website. I write whatever code I want. So if a request goes out internally from a website, is when a course vulnerability happens. Ki, shit, net banking servers got hit. So what can netbanking.hdfc bank do? They can be like, yeah, bro, we are enabling course only for HDFC bank, which is something that you did. But that doesn't mean that this endpoint I can't hit from Postman or from my browser. I can still do this. That is fine. I can still do this from Postman. I cannot do it via a fetch call. A fetch call is where it will get blocked. It will not get blocked on, if I paste it here, because, then I'm sending, it understands I'm not internally sending it. The browser is what's blocking the CORS request. Browsers implement CORS as a protocol to, prevent requests going out and show you the red thing. So if you do it in Postman doesn't care. Let's the thing through. Good question. In week 16 offline class, you said cookies work differently on mobile apps if I am accessing by Express backend using React Native. Yes. So the thing about cookies is when the server sends you a set cookie header, you ask good questions. When the server, if this is your client browser and this is the server, whenever you send the set cookie header from the server, it automatically gets set/sent in every future request, the cookie set. Mobile app doesn't do that. Mobile app, you have to just parse the set cookie header, store it somewhere in, async storage, and then keep sending it again and again. That's the difference. Finally, I solved hot reloading with Docker. I was able to bind mods. Nice. Sounds good. And congrats. One more Notion block and then we'll call it. कहाँ गया? दो थे ना? सेम ही थे क्या? Nope, I don't see it. There were two, but yeah, never mind. Akash, Tubby, there you go. Divyam ka Notion doc. Oh wow. Rate limiting doubt. I tried the rate limiting on some website. The thing I noticed is that no rate limiting can send as many requests as we want. Okay. But when we change the OTP in the payload from Postman shell, the response changed. But when the entered different OTP in the password, OTP not matched. Invalid details, and this gives you. But if I change the OTP on the website, copy the request, there is no issue. OTPs, I have this thing. So they are sending X request code which changes with OTP. Can we extract the script? Oh, wow. Okay, so you went to a website, you tried the standard OTP hack, and you said it gives you invalid details for some OTPs, but for some other set of OTPs, it gives you some random response. Is that what happens? Seems like that is what happens. But if you send the right OTP, then this doesn't happen. But why is this a problem? Why can't you still brute force? Some of them might return you some weird data, but one of them might hit right and might return the right data. Is something I would assume. But yeah, tag me. I will happy share details. Basically, put the call request, whatever you're having here, inside in a thread on Discord, and I'm sure people can help. I can help as well. You want to exploit this website eventually, right? So yeah, if there is a bug, I'm sure people would be super excited to try to fix it or find it. Just post it on Discord. I don't have the mental listing to debug this right now. But I understand if I understand your problem correctly, you're saying with the right OTP, it gives with some OTPs it gives you some response that says invalid token. With the other OTP, it gives you some random response. And I don't know what the problem is after that and why you cannot brute force. But let me know. Maybe there's a problem I don't understand yet. Create a Discord. What do you call it? Thread, not thread. You get the idea, right? The feedback section. We create a post and then let's try to hack this together there. Calling it, guys. Thank you and have a good night. I will see you guys next week.